Hey guys, and welcome back. So far in this unit, we have been talking about matter and forms of matter, how matter changes, and we are wrapping up with switching gears a little bit and talking about forms of energy. So this is going to be one of our last lessons. We're ending with energy in this unit. So go ahead and make sure you have your note template ready, and let's get started. So first of all, we have to define energy so that we know what it is. And energy is just the ability to do work on objects. So we'll talk a little bit more about this in our second quarter when we start talking about more physics concepts. But right now, all we need to know is that there are two forms of energy. So there's kinetic energy and then also potential energy. So kinetic energy is energy of a moving object because of its motion. Okay, so think of kinetic energy of an object in motion. Potential energy is stored energy due to an object's position. So an example that's really typical that we use is talking about a pencil. So if you were to take your pencil right now and hold it above your head and keep it still, it has potential energy, right? So it has the potential due to its position. If you let go of that pencil as it is falling to the ground, it would have kinetic energy because it is in motion. So kinetic energy, energy from motion, and potential energy is energy due to position. So there are all different kinds of energy. There's mechanical, thermal, chemical, light, electrical, nuclear, sound, and it can be transferred or converted from one form to another. Now, we will eventually talk about all these forms of energy in this class, but today we are going to focus on thermal energy. Okay, so the name of the game today is thermal energy. So thermal energy, you've probably maybe heard of this before. So if you think about especially like sleeping bags or camping gear, maybe in the winter, if you have like a jacket that has like thermal technology, thermal energy is just going to be referring to heat. So this is the total energy of the particles in a substance or a material. So we're looking at the energy in matter, which we've been learning about in this unit, and how it moves. So all objects give off thermal energy. And an example here, we've got this little ice cream cone that's melting. The ice cream melting gains thermal energy because it's going to be taking energy on, and we'll talk about that in these next slides. So let's talk about thermal energy and the differences between temperature and heat. So temperature is the measure of the average kinetic energy of the particles in a sample of matter. So the more kinetic energy, the higher the temperature will be. Okay, so objects with higher kinetic energy have higher temperatures. Thermal energy is the total energy of the particles in a material. And remember, kinetic energy is the movement of those particles. So the faster they're moving, the more kinetic energy they have. The more kinetic energy they have, typically the higher the temperature. The potential energy, again, are the forces within or between particles due to the position of that object. So the sum of the kinetic and potential energy of all the particles in an object is the thermal energy of the object, okay? So thermal energy is the sum of the kinetic and the potential energy. Now, you're not going to have to do calculations for this, but we just do need to know the definition of thermal energy. So thermal energy will depend on temperature, mass, and the type of substance as well. So we have an example here, and let's take a look. It says, which beaker of water has more thermal energy? Okay, so we have two temperatures with the same exact temperature, so 80 degrees Celsius, that's pretty warm. And then we have two different volumes, so 200 mils on the left and 400 mils on the right. Now remember, thermal energy is the sum of all the kinetic and potential energy, and it is dependent on mass. Okay, so how much of a substance there is. So if we take a look, there is more stuff, there's more material in object B, and because they're the exact same temperatures, just more of B, B is going to have the higher thermal energy. Okay, so it's got the same temperature but more mass, so it's going to have a higher overall thermal energy. Now heat is thermal energy that flows from a warmer material to a cooler material. So like work, heat is measured in joules, so it's in J. So if you see that unit of measurement, it's just a J. This is just a way that we measure heat. So like we measure volume of water in milliliters. Maybe we measure distance in meters, kilometers, things like that. Joule is just a unit of measurement. And this is going to be a transfer of energy, so heat moves, okay? So if we take a look at this, and we have two different scenarios here. Again, on the left-hand side, we've got maybe like a bucket of water or a beaker of water that is 80 degrees Celsius. So the temperature of the water is 80 degrees Celsius, which is pretty warm. And then on the right-hand side, we have one that's 10 degrees Celsius, which is cooler. So if you are holding these, person A would feel like their hand is warmer. Person B would feel like their hand is cooler. The reason for this is because heat always flows from areas of warmer or higher temperatures to lower, right? So on the left-hand side, that 80-degree water is going to be warmer than your hand. So you feel the heat transfer from the water to your hand, so your hand feels cooler. On the right-hand side, that 10 degrees Celsius water, your body temperature is higher. So your heat is going to go from your body to the water. Okay, so the heat is being transferred from your body, which is warmer, to the water, which is cooler, and then therefore you're going to feel like the water is cool. Okay, so that's how that works. Heat transfers from highest to lowest, so higher temperatures to lower temperatures. So heat is the flow of a thermal object from one object to another, and remember, heat always flows from warmer to cooler objects. That's going to be one of the main things to remember today. Heat always flows from warmer to cooler objects. Okay, so again, an example, the cup is going to get cooler while the hand gets warmer. And here the ice will get warmer while the hand gets cooler. Again, this mug is going to be warmer, so the thermal energy is going to transfer from the mug to the hand. So the hand will get warmer, the mug will get cooler, and then in this case, the heat will transfer from the hand to the ice. So the hand will get cooler and the ice will get warmer. Okay, last thing we have to talk about today is something called specific heat. And then that is, of course, the symbol for specific heat. So this is just the amount of energy required to raise the temperature of 1 kilogram of material by 1 degree Kelvin. So that is the definition of specific heat. And here are the units. So in joules per kilogram per Kelvin or in joules per kilogram per degree Celsius, depends on how you see it. Doesn't really matter what the units are for the specific heat, whether it's in Kelvin or Celsius, we just have to be able to read the table, and I'm going to show you how to do that here. Okay, so in this example, it says which sample will take longer to heat to 100 degrees Celsius. So specific heat values are pretty easy. You're just looking for the value that's the highest. So the higher specific heat that an object has, the longer it's going to take to warm up and the longer it will take to also cool down. Okay, so in this case, we've got aluminum versus copper. We would look at our table and we would compare these two metals. So aluminum has a specific heat of 920 and copper has a specific heat of 235. So 920 is of course higher than 235. So that just tells me that aluminum will take longer to heat up and it will also take longer to cool down. So really the application of this today is I need you guys to understand where the flow of heat will go. So it always goes from warmer to cooler, right? And then understand what impact that's having on the object. And then also, if you're given a data table of these specific heats, be able to tell me which object will warm up the quickest, which one would warm up the least quickest, right? The slowest. So the higher the specific heat, the longer it takes to heat up and the longer it takes to cool down. For these at the bottom, like copper and iron, they would heat up really quickly and they also would cool off really quickly. Okay, so that's what I need you guys to know for today's lesson on thermal energy. If you have any questions, let me know, and if not, you can move on.